Okay, I actually want to pick up where we left off, excuse me, in the last video, because it's worth explaining this difference between an independent measures t-test and a repeated measures t-test. I think it's worth pursuing a little bit more. Here are the numbers, right? If we want to just reorient, these are the people who get no caffeine. These are the people who get the caffeine. And we measured how many seconds it took them to get their first 5 words in a word search task. Okay? So here are the data. That's it, man. I mean, the data are the data, right? So we're going to first talk about the independent measures t-test, sometimes called a between measures t-test, where we have, these are different people, okay? Subject 1, subject 2, subject 3, subject 4, subject 5, subject 6, 7, 8, 9, 10, 11, 12 people separated into this, okay? I want to explore a little bit. I'm going to leave the data where it's at. This is what we looked at in the last video, but I want to explore this a little bit. Subject 1 took 30 seconds to get the first 5 words. Subject 7, a different person, took 23 seconds. Okay? Likewise, subject 2 took 12 seconds, subject 8 took 7 seconds. Now, here's the deal. I don't know why this person took less time than this person. It could be due to the caffeine, right? It could be due to the caffeine. But the fact that these are 2 different people, the difference that we see here may just be due to individual differences. This person might have had more experience with word search, or they might be more motivated to do well, or their vision might be better. Okay, any of those things. Or it could be because of the caffeine. Okay? And so that's the question that we have when these are 2 different people. And so we don't know where this comes from. We don't know where this comes from. And when we talk about the variability, we can say that not everybody's at 23, right? Here's the sum of squares. Yeah, the sum of squares. We have sum of squares here. Now, as a teacher, when I'm trying to make this point to you about the 2 different t-tests, what I want to do is I want to have a group of scores with lots of variability this way, okay? And potentially the caffeine has only maybe a small effect, right? 4.67 seconds. So that when we have our t-test, let's do this, okay? We're always going to look at the difference over variability. This is what we took a lot of time talking about in the last video, okay? Difference over variability. In the case of an independent t-test, we're looking at the difference between the 2 means, right? Divided by some measure of variability. We arrived at this by pooling these 2 levels of variability, because I don't really know where the variability comes from here. I don't really know where the variability comes from here. So we just dump everything into the denominator. This is for between subjects or independent measures. And when we did that, the t value was this. We got 4.67 was the difference here, okay? And then our measure of variability came from the combination of these 2, right? First we get the sum of the pooled variability, and then we go to this measure, and then we put that up into our t-test. If you look back at your notes, what you'll find is that measure was 4.48, okay, which gave us a t-value of 1.12 which we know is not large enough for us to reject the null. We know that this needs to be 2 something or more, twice as big as the bottom. Okay? Now, the other way that we could do this is to use the same person, right? So subject 1, first we're going to have them do no caffeine and measure how fast they do the first 5 words. Then we're going to give them the caffeine. Subject 2, same thing. Subject 3, subject 4, subject 5, subject 6. Okay? Well, what does that do for us? Well, the first thing we have to do is get this treatment difference measure. So down by 7, down by 5, down by 3, down by 5, down by 5, down by 3. Okay? Again, and this is review, but it's worth reviewing here. I can only do this, I can only generate this column if it's the same person, because I can say, well, this is Jennifer here, and this is Jennifer here. It's the same person, same eyesight, same motivation, same, right? And so I can actually do the subtraction here. When it was a different person, there's all sorts of individual differences that are different, and so you can't just subtract and say, well, this is due to the treatment. But we can if it's the same person. Okay? So now we do our single sample t-test here. And when we do a single sample t-test, it's still difference over variability. It's still difference over variability. But what we're doing is we're saying, let's get our single sample. In this case, it's this column. Okay? And we're going to compare it to 0 precisely because, if the caffeine did not have any effect, we would expect to see zeros here, okay? Or something around 0, okay? And then, instead of pooling this variability, what I'm really doing here is looking at the variability in the treatment. And in a way, let's think about the sort of the reciprocal of variability, and that is consistency, right? So we're looking at how consistent the treatment effect is, or how variable, right? It's just reciprocal. And then that's going to go into our denominator. But what happens now is that even though this person took a long time to find the words, it took a longer time to find the words here too. This person was the fastest and was tied for the fastest here. So we're able to explain some of this variability, what we refer to it as accounting for the variability. I mean, it's still there. These numbers are variable. These numbers are variable. But by virtue of the research design, we can account for some of this. We don't have to say, well, here's the variability for the no caffeine group, and here's a different set of variability. I don't know where it comes from. Well, if this person was the slowest with no caffeine, I expect them to be one of the slowest with. If this was the person fastest, I expect them to be fastest. When I say expect, that means we're able to account for some of this variability. We don't have to treat both groups like fresh sources of variability and pool it, okay? So when we do this, if you look back at your notes, what you'll find is the mean here is the same as the difference between the two means here, because this is the difference group. So the numerator stays the same. These are the numbers when people don't get caffeine. These are the numbers when people do get the caffeine. And the numbers are the same. So whether we look at the difference between the means, or if we look at all the differences and get the mean difference, look, it's the same number, right? I wanted to make sure that was explicit. What changes then, what changes in our statistic is that this gets much smaller, okay? Because we're able to account for that variability, we're able to explain some of that away by virtue of it being the same people, then we get a different t-test. And in fact, it's really quite dramatically different. This is 7.5 times the size of this. This is not even twice the size of this, okay? Same numbers, okay? This number is smaller because we can account for the variability. This number represents a level of consistency for the treatment effect because the variability is really low, right? When variability is low, consistency is high. So when I was generating this example, sometimes people think I'm just putting random numbers down. That's absolutely not true, okay? What I wanted as a teacher was to have lots of variability here, lots of variability here, because I knew that was going to be pooled and put into the denominator for this t-test. But I wanted to, when I'm thinking about this example, I wanted the effects of the caffeine to be pretty much the same. I mean, if this number was 17 and this number was 2 and this number was 27 and this number was 5 and this number was 13 and this number was 0, then this would be very high again and we still wouldn't get a significant t-value. Okay? So numerator stays the same. Denominator changes because here we can't account for any of the variability. I got to use it raw. Here I'm accounting for the variability by virtue of it being the same person. Okay? So it's a little tricky to understand. I do want to say, and I really want to emphasize this, so make sure you put an asterisk in your notes, right? Put an asterisk in your notes when a professor says that. That you don't really get a choice. I mean, we're doing this as an example in a stats class. The appropriate t-test is the one that matches the design of the research. So if it's two different groups, then this is the t-test you should do, whether it comes out significant or not, okay? If these are two different sets of people, then this is the appropriate t-test, okay? Did I say that? Did I misspeak? If these are the same people, right, then this is the appropriate t-test. If it's different people, then this is, right? So this would be our within subjects t-test. This is our between subjects t-test. This is our repeated measures t-test. This is our independent t-test. And you can go back to the previous video. You should see it in your notes. It's a different formula. Okay? So those are the statistics. Those are the statistics. I do want to talk a little bit about the problems, because sometimes people will say, well, why don't we always do this as a within subjects design? Because we tend to have a lower denominator with a within subjects design. We tend to. Okay, it's not always the case. So why wouldn't you want this to have a bigger t? Well, because there is a problem, a potential problem with this design from a research standpoint. This is the way you do the statistics, okay? If it's the same people, you do a within subjects t-test, repeated measures. If it's different groups of people, you do an independent t-test, okay? But here's a research design question. I mean, let's suppose that we did this as a within subjects design. We came up with this t-value. We're certainly going to reject the null, and we're going to say it appears that 200 milligrams of caffeine makes people solve the word search faster. And like we've always done, we're going to put our T. Now, the degrees of freedom is 1, 2, 3, 4, 5, 6, because we're doing the difference score. Degrees of freedom is 5 here. But we are going to put our observed T, and we're going to say P less than 0.05. We certainly know this would go P less than 0.01. That's a huge T value, okay? A T of 7. But here's the research design concern. If I give these people the same word search, so I give them a word search without caffeine, then I have them take caffeine. I'm going to wait 20 minutes. I want to make sure it's in their brain, okay? I give them caffeine, and then I see these kinds of results, right? So they got faster in looking for the words. Well, can you think of another reason, other than the caffeine, why these folks were faster the second time they saw the word search? And yeah, I mean, I'm hoping most of you are like, well, it's the same word search? For God's sakes, if I was to do one word search without caffeine, then you gave me caffeine, and I would do the word search again, I would expect, even if there's no effect of the caffeine, I would be faster, right? Because I've seen the puzzle already. Now, some of you might say, well, let's use a different word search here and here. If it's the same people, let's use a different word search so they haven't seen it before. But then my question to you is, well, maybe this puzzle was just easier. In other words, I want to use the same puzzle, but if you've already seen it, you're going to be faster even if I didn't give you any caffeine, okay? So when we do a within subjects design, there are some really big issues. People could be tired. People could have had practice. There's pre-exposure, okay, to the puzzle. And so it may not be the caffeine at all, but just that pre-exposure. Wow, this is a problem. This is a big problem. Even when we did the appropriate statistics, I don't know if this effect is because of the caffeine or because it's the second time they saw the puzzle, okay? And so that's an issue. And these are problems that are generally fall into something called carryover effects. Carryover. If it's the same person here as here, we have to be careful about some carryover effects that may explain these results more than caffeine or just as much as caffeine. So we have things like pre-exposure. In this case, pre-exposure to the puzzle. So I've seen it before. So in a way, I've had practice is another carryover effect, okay? Fatigue. Now in this case, if the subjects were fatigued, I would expect a higher score here. But I'm just giving you these potential problems generically when you do a within subjects design. So this is problems or potential problems, okay, within subjects design, right? We have these potential carryover effects. Well, you know, I'm not the first person to acknowledge these potential problems, and neither, you know, scientists have thought about this for a long time. There is a way that you can get around at least the pre-exposure, right? If people are doing better because they've seen the puzzle before, well, then what we need to do is, for half of these subjects, I want to first give them caffeine and have them do the test, and then give them, test them with no caffeine. So we're going to do the experiment sort of in the opposite direction here, okay? Take your time now. So these 3 subjects get get no caffeine first and then caffeine. These are tested with the caffeine first and then the no caffeine. And the numbers are likely to change, folks. The numbers are likely to change. I'm just showing you that you can do this in the opposite sequence. This is called, if we do this, it's called counterbalancing. There's a reason why we call it counterbalancing, because we're balancing the effects of pre-exposure so that some people, the effect of pre-exposure should influence these scores. Some people, the effect of pre-exposure should affect these scores. We put all this together, then we can see if it's caffeine, because if it's not pre-exposure, then we are still going to see our low scores here, right? The caffeine will still have an effect. If it's pre-exposures, then half the subjects will show lower scores here and half lower here, and it will end up counterbalancing the effects of pre-exposure. And this works for practice, and this works for fatigue. But these are more sort of experimental design issues, research method issues. Once we have the numbers, then we do our statistics that are appropriate. Okay, once we have the numbers, we do our statistics that are appropriate. But you can expect someone to raise their hand at a conference presentation, or if you're trying to get this research published, and they say, well, how do you know that this is not an effect of pre-exposure and not caffeine? And you would be unable to answer that question. The point here, folks, is things get complex, and there's different ways to interpret data. And that's why I get frustrated sometimes when people look at this stuff casually, and you can really get misled if you don't know potential problems with the research. Okay? So if we want to avoid these potential problems, well, they all go away if you're using different subjects. If these folks are different subjects, then there's no pre-exposure, because this is the first time the person saw the puzzle here. This is the first time the person saw the puzzle here. Okay? So the advantage of, and maybe we can do this. Between subjects within subject design. And this might be called an independent measures or a randomized block design. This might be called a repeated measures or pre-post or correlated measures, okay? So we can say, well, what are the advantages? The advantage here is no carryover effect. I mean, you're only testing the group once. No carryover, no practice, no fatigue in terms of the independent variable. Here, the advantage is we can account for individual differences. How do we account for that? It's the same person in the no caffeine group and in the caffeine group. So, same person means we've got same gender, same height, same eyesight, same IQ, same motivation, same experience with previous word search, any of that stuff is individual differences, okay? So with the repeated measures, we can account for that because we're using the same people. But, of course, there's disadvantages, okay? And this is another one of those things that people sometimes, it's like, well, which one should we use? there is not a correct answer, because the disadvantage here is that individual differences need to be pooled. That is the variability, right? Need to be pooled. And so goes into the denominator of our t-test. It ends up typically making a larger number, so it's harder for us to reject the null. Okay? What's the disadvantage of a within subject design? Well, potential carryover effects. Use the same subject twice, they could be fatigued. Use the same subject twice. Well, they could get better because they had practice. Use the same number twice. Well, they were pre-exposed to the conditions, so they're not as nervous, or they remember where the words are, or whatever. So, and if you notice, this is a 2x2, right? If you notice, this is a 2x2. Whenever you have a 2x2, pay attention. We see it a lot. So, what is the appropriate design you should use? Well, that depends, really depends on what you're researching. If you think there's going to be a lot of individual differences that might influence the power of your study, of your research, of your statistics, you might try to use a within subjects design, but you have to worry about carryover effects. And we can remedy this sometimes with counterbalancing. Okay. We can remedy this sometimes by making sure that we do a good experiment so there's no confounding variables. So there's no correct answer. And when you're in a lab or in an agency, people will use one or the other based on their best decision making, taking these things into consideration. Okay, so please email me questions if you have them, or we can Zoom or whatever. But I just wanted to follow up on this whole thing with within subjects versus between subjects design, or independent measures versus repeated measures. What you decide to do as an experiment, that needs to be then matched by the appropriate statistic. That is, you don't get a choice with your statistics. Once the research design has been set up, then you do the appropriate statistics.